And just give you a very brief update. And I think last year we did the combine upgrade. That combined with purchasing 2013. And so originally it's a Schliemann's harvest program. And then after we bought another Zen 150, we have the harvest master program on it. And I think it's more efficient and we liked it. So we upgraded this system to the harvest master program. Now we have two. Zen 150 has the same harvest master program, and it cost us about $40,000, and I think it's worth it. It's more efficient now. Before that, older program can only harvest about maybe 70 plots per hour, and also have a wind effect. If it's a very windy weather, and then if that wind direction directly hit that the scale side, then we have to stop and wait until the balance got to close to zero. Then we can restart. I mean, it takes. I mean, it just holds us forever when it's windy. So now that effect was eliminated, and then we are able to harvest per hour at least 100 plots. So it's more efficient now. We have two good combine now. And as long as for this year's for next this breeding cycle, we have this that many breeding lines or populations here. I want to just point out we made more crosses last year, and so we have 300 or close to 430 the F1 populations, and also we made more head selections, and then we have this year have over 24,000 head rows now. It's compared to last year we have about 20,000, and then the first year the yield trial we also had more lines from compared with the last year. Now we almost hit to 800 lines. The reason because I think I think because now we have two good combines, we have more power to do the harvesting stuff. Before we are kind of limited by the capacity, the combine capacity, and also I mean with the other things. And so now we are in good shape. I think I will continue to increase the lines in the first years in the preliminary yield trial, and because there's a bottleneck when we harvest those head loads. Basically, before we use the sickles and cut every head loads, and it takes forever to cut like just a few like 500 or 600 loads, and now we use a different way to approach that. So I think cut about 1,000 head loads is not a very big deal. So with that, I think we will be able to try to get to the goal like first year's year to try will reach to 1,000 lines at least. So in the future. And then some research progress on the wheat streak, and we already had two varieties released for the have the 21 degrees Celsius resistance on the wheat streak mosaic virus. I continue to try to improve that resistance. So I think I found one has at least I think 24 degrees Celsius now. One line I confirmed last year in the growth chamber, and I tried to confirm this year, but at least I confirmed that 21 degree, but later I'm kind of short of out of seeds. I cannot confirm it at 24, but I will continue to confirm it. And so this kind of resistance level almost as good as the WSM3 gene actually. WSM3 can only also hold at 24 degrees Celsius. and also continue working on the critical mosaic virus resistance. So far, I already identified 2 elite lines with at least moderate resistance in the field. We inoculate those lines in the field and then see how they perform in the field. So actually those lines, all our, at least I haven't found any conventional lines had the, total resistance to the critical mosaic virus as WSM1 or WSM3, but in the field you can see the difference after you inoculate. And some just didn't have much damage, almost similar as a resistance. So I call this kind of called moderate resistance. So and then we also developed some derived some over 30 DH lines. Those are derived from cross. At least one parent has some moderate resistance to the critical mosaic virus, and this year is we planted in the field to try to we already inoculated and then try to see the performance of those lines there. Also worked on the WSM1 and WSM3 genes. Now we have 2 DH lines. They already they carry WSM3 genes, and they're already in their third year's yield trial in AY1, and then 2 DH lines has WSM3 gene that's in their second year's yield trial, and then we have more lines in the first year's yield trial, and the 4 lines, actually 4 DH lines, we had both the WSM1 and WSM3 gene. They're all testing in the yield trial this year. And we have some other progress here. We also have 3 DH lines have the BX7OE genes. Then these 3 lines already in the AY1 test this year. And also 2 clear field genes in the KIN. That's I will talk a little bit more in the later. This already 2 lines already in second year's second year's KIN test this year, and 3 more clear field genes in AY1 test, and 5 possible ones in the P1 and the first year's yield trial, but they need to confirm use a spraying method to confirm that they have 2 genes. And for coaxium, I have derived 22 progeny lines from the resistant parent, and 2 actually already be confirmed. They have the coaxium resistance, and they are in the second year's yield trial. The others just need to be sprayed this year for confirmation. And then I also have derived 14 solid stem lines. They are in the second year's yield trial. And then I also kind of developed over 300 progeny BC backcross 3F3 lines from derived from that 14H180. That line we didn't release because of the stem rust susceptibility. So, and we backcrossed into that YR17 gene. So all this progeny rows has the YR17 genes with the marker selection. So we'll see what can come out from this over 300 lines. And other activities, and I'm working on that genomic selection this year. And we already genotyped over 1,000 lines, and about over 200 lines we have the phenotype data. We use that as a training population. Then, and the other lines are just those P1 lines. And this year's P1 lines, I want to predict the breeding value for those lines. Also, look next time after we harvest, I want to look at both the predicted breeding value and the phenotype data in the field to select those those P1 lines because there's no wrap and only one location. So I want to more accurate to select those lines. So I always, I think the past winter I spent several weeks and set up the R coding pipeline, and now I think I already set this pipeline up, and I already predicted those P1 lines, and just wait to the harvest until the harvester gets the phenotype data from the field to see how accurate it is. And I used the BioCat, the supercomputer class on campus to do all the analyzing and the stuff. So I don't need my own computer. Actually, it's very good. I just control from my own computer over the campus supercomputer. So it's unlimited memory size. That's very good. And also try to build a high throughput phenotyping program this year. And I'm gathering all the equipment I need, the drone, the camera, and all the software stuff. And then I'm sending my technician to Salina for pilot training to get the pilot license. So some promising breeding lines for, so those, I have totally 4 promising lines and 3 red and 1 white. So those lines will not be released this year, but I will, if they are good this year, will be proposed for a big increase this year, then will be potential release next year. So the first one, actually these are 2 sister lines, and you can count it as one because I thought maybe there's some difference on the stem rust or on the quality, so I still keep them and try to figure out maybe this year to just to keep a one. So these 2 are the Clearfield, 2 gene Clearfield wheat, and the medium late, medium tall, and also the coleoptile length is long. And it don't have the wheat streak resistant gene, but in the field, inoculation test seems like intermediate to the both wheat streak and the tritic mosaic virus, and has a moderate resistance to the stripe rust, and good resistance to the leaf rust. And the stem rust is kind of intermediate to the moderate susceptible. And we'll see more data this year in the field about the stem rust. It also has the soil-borne mosaic virus gene, and the Fusarium heterovirus scab, and the kind of intermediate reaction, and the Barry yellow dwarf with moderate resistance. So it did very well in Western Kansas. We have very good yield potential and also good drought tolerance. The last 2 years, it's always beat the broad seal. By the way, it is derived from broad seal, and so I guess it can fit to Western Kansas. Also, I think it might also fit into the Central Kansas. I never compared with the Clearfield wheat from Oklahoma, though, in the Central Kansas. I don't know how it compete with those Oklahoma Clearfield wheat. So, but I think we will try. And the second red line is 18H111. I would just mention that all these breeding lines actually have very good straw strengths. So I'm not going to talk one by one. So they all have good strengths. They stand up very well. And this second line actually is it's just a conventional line. It's red and medium height and medium maturity. Good high yield potential, very good drought tolerance, and it has a wheat streak resistant gene, and tritic mosaic virus is the intermediate reaction in the field, and has a moderate resistance to the stripe rust, but the leaf rust is just intermediate, and they have a good stem rust resistance, and also has a hessing fly resistance. And third line is also red, and it's called 18H124. it's medium tall, medium late. The coleoptile length is very long, very good yield potential, also very good drought tolerance. And it doesn't have the wheat streak resistant gene, but in the field, it kind of very kind of moderate resistance, and it have some minor symptom, but I don't think it affect the yield performance. So I call it moderate resistance, and it has very good resistance to the all three rusts, the stripe rust, the leaf rust, and stem rust. Was derived from Joe, so this kind of rust resistance kind of maybe come from Joe, and good baking quality, this line. And the last one is white wheat, HW106, and it it come from a cross between Allen's line and then my line. So I have medium height, medium maturity, and the yield wise is I think dry in the dry year is better than Joe, and most of the wet year actually it's better than Joe, and some years is similar as Joe. So yield wise, it's very good, and so it has good drought tolerance. It's better than Joe at least, and has a wheat streak mosaic virus resistance and a good stem rust resistance. Stripe rust resistance is moderate, and also has moderate resistance to the body yellow dot virus and a good baking quality. So I think, well, I mean, this year, all these lines they have a small seed increase, and we'll see how it performs this year. So we'll go from there. BX7OE, actually, kind of at the beginning, we thought, well, it come from a snow mass, but originally come from our program. There's one breeding line, and then snow mass incorporated something from that from our line, and then eventually what tested is BX7OE. But that snow mass actually have both high water absorption and the very strong mixing tolerance. And we thought it's just from the BX7OE allele, but once we test, because our actually the case of Vanada also has the BX7OE allele, but actually it only has a very good water absorption, but doesn't have that good mixing tolerance. So in my opinion, I think it should have will have other allele involved about that mixing tolerance. So and so I just mentioned in my presentation we have three DH lines derived from snow mass. So I have the BX7OE gene, but we haven't really tested the quality yet. So we'll see how the quality come out from the three BX7OE DH lines. And but I have some populations kind of derived from the BX7, derived from snow mass. So some line has the BX7OE, some line don't have it, and then I might try to find some people to test it, and then we will find out, some allele beside the BX7OE can affect the quality, something like that. So then if we can find out that allele might be good for us for our future breeding. So we need to put both the BX7OE and then another allele into our lines. Not only, I don't think the BX7OE allele itself will have the, I mean, based on our experience, I don't think that will bring the good mixing tolerance.